This lesson focuses on different values of functions. Intercepts are where a function crosses the x or y axis. If we have a function and we graph it, any place that the function crosses the y-axis is called a y-intercept. In this case, y-intercept is -2. Any place that that function crosses the x-axis is called an x-intercept. In this case, we have 3, -4, -1, and 2. Other values of functions that we're going to look at are the domain and the range. The domain is a set of all of the x values used in the function, and those are the input values, or numbers we plug in. A range is a list of all the y values for that function, or the outputs, answers we get back out after we plug in the inputs. We need to be able to find the range by inputting all of the domain values into our function. So if we have the function where h of x equals 4x minus 1, and the domain of -2, -1, 0, and 1, that means we're going to plug in those values to find the range. Then we can go ahead and graph that function. Let's make a table. If we have all of our input values, we're going to plug them in for x in our formula one at a time. So when we plug in -2, we get -9. When we plug in -1, we get -5. When we plug in 0, we get -1. And when we plug in 1, we get 3. These outputs are our y values as we graph this function. First, let's list the range. Since all of these numbers that we got back for y are our range, we're going to put them inside of the squiggly brackets. Then we can graph each pair of x and y as a point, using those as the coordinates for each point. So -2 and -9 are the x and y coordinates for the first point, and so on. Next, we're going to look at exponential functions. We've already talked a lot about linear functions. A linear function uses y equals mx plus b and is a straight line when you graph it. Exponential functions are a curve. They use the formula y equals b times r to the power of x, where b is the y-intercept and r is the ratio, or the number that we multiply by. In the case of our example, we've got y equals 10 times 0.5 to the power of x. The y-intercept is also called the initial value, or starting point. If we look at our graph, we can see that it starts at the y-axis at 10, and we also have a 10 in the y-intercept spot of our equation. This means that the function starts at 10. Exponential functions are either growth or decay. Growth means the exponential function is increasing, and decay means the exponential function is decreasing. Since our graph is headed downwards, this is a decay exponential function. Another way to look at the growth and decay is to use this formula to find the percent of growth or decay. We take the ratio, subtract 1, and times it by 100 since it's a percent. Since our ratio is 0.5 in the formula that we have for our example, we're going to take 0.5 minus 1 times 100, which equals -50. Since it's a negative number, that means this is decay, and 50 is for 50%. If this had been a positive number, it would have been a growth function. The last thing we need to know about exponential functions is how to find the domain and the range. Remember, domain are all the x values, and range are all the y values. When we look at the graph of our exponential function, we have to keep in mind that the x values go from left to right, like the x-axis, and the range of y values goes up or down, following that vertical y-axis. Let's look at the range first. If you look at how far this function goes up or down, you'll see that there is a dotted line, which is called an asymptote, which means that as that graph gets closer and closer to 5, it never actually hits 5. It just gets closer and closer and closer as it heads towards -infinity. An asymptote is never crossed, which means that this function is always above y equals 5. it never goes below that line. That means our range is that y is greater than 5, since the entire function is always above 5. Remember, range, we're going to look at how far up or down the function goes. Domain is how far left or right the function goes. If we look at the function, it continues to the left, it also continues up and to the right. Since it continues in both directions, that means that this domain includes all of our real numbers. We would write that saying that the domain is all reals.